I will be looking at one question which will encompass what we did this morning, reflection, and Mrs. Mundell Thomas will take you through one on enlargement, or two actually on enlargement. All right, so here we go with the question. This question is May 2019. And so we have our triangle ABC, which was already drawn for us. And so I'm going to give you about 2 or so minutes to take this off, get your graph papers, and we are going to draw the triangle ABC. So it's a triangle ABC with vertices A, 1, 1. We can look on the graph and see that that's the coordinate there for A. So A, 1, 1, B, 1, 4, 1 on the X, 4 on the Y, it's labeled there, and C, 3, 1, 3 on our X-axis and 1 on the Y-axis. And so that is triangle ABC with vertices A, 1, 1, B, 1, 4, and C, 3, 1. So it is shown on this screen as we speak. So triangle ABC is mapped onto triangle LMN by a reflection in the X-axis, followed by a reflection in the Y-axis. Now, this is your opportunity to apply some of what was said this morning. We don't have GeoGebra, and so we're going to literally do this together. So we're going to be drawing the triangle LMN after we have done a reflection in the X-axis followed by a reflection in the Y-axis. And once we have done that, we're going to label the diagram and label the diagram LMN. So let's explore what is going to happen. All right, let me know if you have drawn the triangle ABC. Giving you a few minutes to do this. Yes. Awesome. Great. You already did it. All right. So my question, just before we actually get to the drawing, think about it. If we're doing a reflection in the X-axis, where do you think our image will lie? And now notice that it's a reflection in the X-axis followed by a reflection in the Y-axis. So it's a double reflection. All right, so which one of the axes are we reflecting in first? Horizontal or the vertical axis? Let's see if you remember. Okay. All right, horizontal, awesome. All right, so let's look at what is happening. We have our X-axis, and so we are identifying our reflection line or line of reflection, and that's the X-axis. And so we are going to use some of the properties that we looked at earlier. And one of the properties that we looked at as it relates to the distance from each point to the mirror line, what did we say about that? Let's check to see. What did we say about the points? We're seeing the broken line here. Come on, man. We're almost at the end of today's workshop. I know you would have had a long morning. So let's see what's happening. What can I say? All right, so let me increase my volume. I'm asking you, what can you tell me about the distance from A to the mirror line? And what should I do in terms of the image that will come up right after? Okay, so it's 1 unit away. So what are we expecting then? That in our reflection, the image point A prime should be 1 unit away. Awesome. All right, and that point is coming in nicely. What about our B? So we have the coordinate for B. Where would our point or B prime be located? All right, 4 units away. All right. Remember when we were looking at some of the points, what did we see when we were doing a reflection in the x-axis? You remember any of those points coming up? But in the event that you're not remembering those, because it's actually a graph, we don't have to use we don't have to go to the abstract. We don't have to go to a generalization. We can actually count and see. And so that's beautiful. So let's look. We're going from the mirror line 4 units up to B, and therefore, or B prime will be 4 units away from the mirror line. And same can be said about our C prime, and we would have completed the first reflection in the x-axis. So we are now being asked to reflect in the y-axis. Let's see, our y-axis is now coming up. It's been brightened, and I'm going to label that. All right, let's go. We are now going to do the reflection. What do you think we're reflecting? Let me see. Question said we're reflecting ABC onto LMN by 2 reflection, reflection in the x-axis and followed by a reflection in the y-axis. So can you tell me which quadrants, where will my next reflection fall? Will it fall up here, or will it fall down there? In the second quadrant or in the third quadrant? Let me know in the chat. The second one at the top. Is it okay, so you're saying it's the second one or the one in the lower left corner. All right, let's see the top left. Okay, so based on the question, you are saying that after we have done this reflection, so we're doing a double reflection. So we're reflecting ABC twice. We're reflecting it once in the x-axis, and then we're going to reflect it in the y-axis. So what do you think the question is asking you to do here? This is a question that you would be given. Where do you think this would lie? Want to get some more responses? All right, let's see. So you're still thinking that we're reflecting the first image. Actually, in this case, because it's a double reflection, so it's as though we are folding along the x-axis, and then we are folding what we got on the y-axis. All right, so it's the same. So even though we are seeing the A prime, B prime, C prime, you're looking at the final. So we want to see where ABC would actually end up, having gone through a reflection through the x-axis and then the y-axis. All right, so it's not as though I'm coming again to reflect the same ABC. So I'm doing one reflection with the same object, and then I'm reflecting that image again, because I'm trying to see where ABC would fall, having done 2 reflections. Am I clear? Are you getting it? All right, so let's see, so we're moving now along the y-axis, and that is correct. Yes, -1, 1, -1, -1. Awesome. B, we can populate that, and now we're bringing in our L, because at no point we saw the L coming up, but we are in the final reflection. So we can populate in using LMN. And so we now would have reflected A from A to A prime, and it's now in its final position here at -1, -1. We would have reflected B in the x-axis, that would give us B prime, and then we're reflecting it again in the y-axis, and now that will give us M, our final place of having reflected it a second time. And then our third and final point would be C, having reflected it in the x-axis, and we would have checked the distance. We are now reflecting it again, so it's 3 units to the right. And so now we are reflecting that in the y-axis, and likewise counting the distance, it will be 3 units. And so we have the double reflection. Now my question to you, what if the second reflection was not there? what would this look like? What would this double reflection look like for you? So the question didn't ask us that, but I just want to take it a bit further. When you look at ABC and LMN, we were to fold it and I ask you for the mirror line that will cause ABC to map onto LMN, what would that line of reflection be? So let me be clear. I would like to now reflect ABC to LMN. And I'm going to do some paper folding and I'm going to align my B. By the way, can you align the vertices for me? What points would be aligned to what? What point would be aligned to A? What point would be aligned to B? What point would be aligned to C? So what point would be aligned to A? So we're at A, and in the final reflection, okay, let's see what's coming in the chat. All right, so you're saying A11 is now 1, -1, -1. Awesome. All right, can we see what B would be? Yes. All right. So we did not do rotation. And I know some persons might ask, how did I populate this? Or why would I have asked this question? No. And so if you were to go and look at when we had done transformation in terms of rotation at the center, the origin, 180 degrees, you'll realize that that's actually what we were doing here. If we were actually looking at ABC, would realize it's actually a rotation about the center 180 degrees. So the question didn't ask you for that though. However, I was just stretching you a little bit to see if you are able to look at this double reflection and see what was similar about it. Because notice, we didn't just stop with the reflection in the x-axis and the reflection in the y. It's actually a combined thing. And the reason why I allowed A prime, B prime to stay there is for us to realize or to just check to see, because if you didn't put that in the exam, that would be fine, because some students might have done it. Say mentally, you did it here and then you're showing what LMN is, but that's fine. So I was just checking to see for those persons if you were aware of what was happening, something different. And so this is the only question we gave you today, but there are tons of questions that you can type in. Go to the CSEC website, or if you have past paper questions, look for those questions that speaks to reflection. Some questions though might have reflection and along with the reflection, it might have an enlargement part to it, or you might have a reflection along with say a rotation, just about anything. So this is just the second part of the first set of transformation that was done. But when it comes on to CXC, they're going to be merging the questions. And so once the questions are merged, you should be able to look at any one of the transformation and see where we're going. All right. And Mr. Lim is so ably provided you with a link to get some CSEC extra past paper, because what we're doing today is not going to be sufficient to cover, just an hour of tutorial going through 3 questions won't cover all the type of questions that you will see, because you will say, oh, but they didn't give us any rotation today. Oh, but I see a question and there's a reflection and a rotation to it. It doesn't mean that you can't do it, because as we would have said before in previous sessions, we would have looked at rotation and translation, and you can go right ahead and look at those. Thank you very much, Mr. Limi, for those links. Students, make sure you copy those links, open them up open them up and have them there, save it, bookmark the links, and so that you can get access to this after we are through with our session. All right, so let's move on. We have another question, And I do believe this question is an enlargement question. This is not the final question, but this is the penultimate. It's almost the last one. So I'm going to have Ms. Mundell Thomas take you through this one. And then the very last question, and that will be it for you for today. All right, Mrs. Mundell Thomas.
All right, so this question is actually a part of a CSEC question. So as Ms. rightly said, the question may come with multiple transformations present in it. All right, so just be mindful of that. So for this question, it's coming from the January 2022 exam paper, and it says the diagram shows triangles X prime, Y prime, Z prime, and X double prime, Y double prime, Z double prime, drawn on a square grid, right? And we're seeing the image there. Triangle X prime, Y prime, Z prime is the image of triangle XYZ after an enlargement of scale factor 2 with center 5, 1. So stick a pin right there. Notice triangle XYZ is not on the grid. So immediately I'm seeing we have a situation where we have the image, but we do have the object. Interesting question. Now we're being asked to draw triangle XYZ, which, as we know from the previous part of the question, is the object of triangle X prime, Y prime, Z prime. So we're to draw it on the grid. Interesting. So in other words, this enlargement has been done, and we're working our way back to the object. Don't think we have done anything like that since morning. So we could not close that session. Yeah, we could have closed the session and not pull this question out because it's very recent and it's really asking us to do something we probably have not done since morning. But with what we have, we can definitely complete the question.
And Mrs. Thomas, might just add that students, what you're noticing, even in the last example that before the question of May 2019, students, when you're given both the object and the image, when it's drawn for you, it's more application, pulling on things that would have been said before. So those are some of the things we want to point out when we're going through the questions. Over to you, Miss.
All right, so we are now being asked to draw the object. So we have the image, and you may be wondering, why is X double prime, Z double prime, Y double prime there? We'll talk about that in a minute. But we're now being asked to draw the object for X prime, Y prime, Z prime. Now we're told the scale factor is 2, which means, what did we say the scale factor tell us? Something about multiplying, huh? So what this is saying to us is that the multiplication has already taken place and we have the image and we are to work back to the object. Now let's find our center of enlargement. We're told it's 5, 1. Now, remember, when we were performing the enlargement, we said that we would have connected from the center of enlargement to the object, and we went straight through. If you remember from the previous session, when we looked at enlargement, we called it an extended line segment, and we said that the image would lie somewhere on that. Now, in this case, we don't have the object to connect to, but we do have an image. So you're gonna have to pause a bit and wrap your mind around this one. I know it's gonna take you a little time, all right, to process all of what's happening. So I'm gonna try to go as slow as possible, but being mindful of the time. So let's do a connection, Mrs. Cameron Edwards. So let's see if we can connect, because we know already from what we did this morning that the line segment, the extended line segment from the center should go through object and image point. So right now we don't have the object point, but all we have is the image point, x prime. What we do know is that to get to x prime, the distance from the center to the object was doubled or multiplied by 2. How do I know that? Somebody tell me in the chat. How can I boldly say that I know that the distance from the center to x prime is 2 times the distance from the center to the object point x? And that's a bold statement to make. Hey, all right, so people typing in the scale factor. Awesome, the scale factor. So it has already been doubled. So how am I going to find the object point? It doubled already, you know, and I'm working my way back to the object. You tell me in the chat what you think I need to do with this distance. Miss why that red dot in. Tell me what I need to do with this distance from the center to x prime. All right, so somebody saying divide by 2. Let's see. All right, so somebody said divide by 2. Okay, good. So I hope you're seeing what is happening here. The doubling already take place. So if I'm working my way back, then even though the scale factor says I should double, because it doubled already and I'm working from image back to object, then I must be halving it. Yeah, man. Yes, Roxanne, you are perfectly correct. Remember, dividing by 2 is the same as halving something or multiplying it by half. So yes, you are on the right track. So basically, we need to find halfway distances for these line segments that we're gonna be drawing. Yay. I like the excitement. Yes, I'm excited for you too, girl. All right, so let's put in the middle, and we can find the middle. We can actually, you know, check to see what are the squares that this line segment is actually stretching across. You can use your ruler in the exam to actually do the measurement of the line segment from the center to x prime and actually finding the halfway mark. It's as simple as that, right? So let's find our halfway mark here, miss. All right, so there's that point, which now means that's the object point x. Yay. All right. And one thing about these questions, you know, once you've done one, the rest to do the other points on the object or image, depending on what the question asks of you, is pretty much the same idea. All right. So again, from the center to y prime, and again, that's already doubled. So I need to half it, or I need to divide it by 2. So again, I can use my ruler to do that, okay, to find the halfway mark. So that point would now be, which point? Who can tell me? That one that just came in. What would that one be? Y. Awesome. All right. I will pretty much do a similar thing for Z prime in order to locate Z or Z. Fantastic. All right, so let's draw in now, because they didn't just say to put the vertices, they actually ask us to draw the triangle, which is the object for triangle x prime, y prime, z prime. Now, as I said, you may be wondering about the part on the other section of the question. So this part was really to focus on the enlargement portion of it. But today in particular, we would have done another transformation. I would have done some before. So at this point, you should be able to at least tell me what transformation is mapping x prime, y prime, z prime, that's the shaded triangle, to x double prime, y double prime, z double prime. At least tell me what the transformation is. And I mean, if you think you have it, I can give me a little additional info. We didn't actually do this question, but based on what Miss would have said earlier about the combinations that are possible on the exam, this was actually asked of you. So can anybody tell me quickly, what would map x prime, y prime, z prime onto x double prime, y double prime, z double prime? Which transformation? Reflection. Or saying it's congruent. All right, so somebody's saying it's congruent, one, and they're seeing that somebody's saying it's flipped, so they're saying it's a reflection. All right, so I won't keep you in suspense. Yes, I agree with you, it's a reflection. Anybody care to make a guess at what the mirror line would be based on the properties that Miss spoke about in her session on reflection? Can anybody make a guess? What is the mirror line? If I say two that is not a line, your line must say something equal. So it is an equation of a line. The line has an equation. So you have to tell me if it's x equal to, y equal to. Well, yeah, since based on what you have, it can only be either of those. Y equals 0, you're sure? That's the x-axis, you know? Galaxy is saying x equal 2. All right, run your arrow along x equal 2 for me, miss. All right. X equal 2. All right. Okay, so I'm asking someone who wants me to repeat, and maybe it will clear up the person who is probably a bit confused. Maybe they weren't hearing. So let me just repeat. I'm asking triangle x prime, y prime, z prime. That's the shaded triangle. I'm asking what's the transformation that maps it to the triangle all the way to the right. X double prime, that's the x with the prime prime. Y prime prime. Z prime prime. I want to know what transformation is mapping the shaded one to that one over the extreme right. All right, someone said it's a reflection, and I agreed with them. And I'm asking, what's the equation of the mirror line? What's the name of the mirror line? All right, so that's where we are. Someone said 2, and I'm saying you can't say 2 because that's not a line. That's not even a point. Your line is named by an equation. So you either have to say x equal 2 or y equal 2. And I'm asking, which is it? All right? Just in case you weren't hearing, hopefully that repeat is clear for you. All right? So I'm seeing both options now. So someone says x equal 2 and another person says y equal 2. So miss, I'm asking you if you can hover over x equal 2. Just follow Miss Arrow now. That line right there is x equal 2. So y equal 2 now would be the horizontal line. Which is it? Good. The x equal 2. Awesome. So this question gives you an idea of how transformations can be combined in a question. All right. So this one brought in enlargement and also reflection. Okay. So just be mindful of that. Good. Can go ahead, miss. All right. This one is pretty clear. We would have done something like this before where the enlargement has been done for you and you're being asked to say what the scale factor is and what the center is. So don't worry, I really want to say something here many times. Students get confused because they now say scale factor K about center C, A, B, and they see A and B and K and say, and they know transformation, you know, but they get nervous because of the variables that are there. Don't be confused, darling. It's the same thing that we've been doing from morning. So the quadrilateral PQRS is, and its image P prime, Q prime, R prime, S prime are there, and they already tell you that it's an enlargement. You don't even have to guess. And all they're asking you is to say what the scale factor is and what the center is. All right. So remember, we would have done this in the previous session. And just in case you missed it, remember, you can always find your center of enlargement by connecting corresponding points. All right, so Q to Q prime, R to R prime, P to P prime, S to S prime. Once you connect those corresponding points, what did we say? Where is the center? Where we find the center when we have done all of that nice connection? How we identify the very center point now? Who can tell me as we close up this session where they all meet? Awesome, Danny. All right, and somebody gone as far as to give me the coordinate. Thank you, Galaxy. -4, it is. So remember, I know they said center C with coordinates A, comma B. So Galaxy, you're gonna lead, you know, because you have identified A and B, because that's what they want you to do. Say what the coordinate is. Now let's talk about the scale factor. Remember, we're gonna have to check now something, a length on the image, and divide it by a corresponding length on the object. And guess what? PQ is one of the easiest lengths to see, not true? And P prime, Q prime, huh? So P prime, Q prime is 3 units. And PQ is 1 unit. Awesome. And so therefore my scale factor is in fact 3. So literally, good, Galaxy. So we have all the things, you know, so we don't have to be confused about A and B and K. Once we know what they represent, then we can easily now say scale factor K is equal to 3. And based on my center, since A appeared first in the bracket, A must be -4, which is the X value. And B, which is our Y value, would have to be equal to 1. Awesome. So that's where we are going to end our session for today. Thank you so much for being with us. We're going to drop in the chat a link for you to evaluate the afternoon session. Not sure why Mrs. playing over that part.
Thomas.
Yes,
I don't
miss.
saw Shanice Brown's question. How do you find it?
I saw it. I'm going to address it.
Okay,
I saw it.
all right.
Yes. So how do you find the enlargement with one shape? Now remember, if an enlargement has already taken place, then the object and image would be present for you to find other things about the enlargement, right? So for example, this question, the enlargement was already done, and you are now asking for specific things about the enlargement, such as the scale factor or the center of enlargement, right? If you are given one shape, then chances are you're being asked to perform the enlargement, or they would have given you something that the enlargement was done and you're to draw the image. So it all depends on the specific question. But if you're given one shape, you may be asked to draw the image or the object, and you're given information about the enlargement. All right. So the one shape may be there. It could be the object or it could be the image. Don't know which one they give. Depends on the question. And you now use the information about the enlargement, scale factor, and so on to actually draw the one that they're asking you for. I hope that is clear. I'm trying to be as clear as possible without a specific
I was trying to go back to something, but we'll have to go way back into the presentation.
Yeah. So Ms. Harris, if you have any further explanation to this, no, don't do that, Miss. If you have any further explanation on that for her, you can probably speak to it. But we're cutting the live now, and then you can probably have that convo with her. Please remember, students, to complete the evaluation form using the link that